Hi there. Hi there. How are you doing? I am good. Thanks to God. Let me tell you some my personal profiles for my desired student. My name is Simman Bakaler. I have been working as an assistant lecturer at Bonga University for 1 years, 4 months and 22 days as assistant lecturer there. I have completed my bachelor's degree in electrical and computer engineering at Walaita Sodo University. While I was been dealing my master's degree at Addis Ababa Science and Technology for 1 year ago in the qualification of computer engineering. The left 1 year is here. In this year, I am defending or preparing my thesis paper for Vanguard Tutors students. I am really have teaching passions being my passions, and I enjoy helping students build a strong foundation in their studies. I especially love working with the learners from KG student to up to grade higher institutions undergraduate students, like by guiding them step by step and making learning simple and easy plus enjoyable manners for my students. With my background in engineering and teaching, I believe every child can understand and succeed when concepts are explained with a patience and real life scenario examples. The student might have be genuine because they have basically real life practical theoretical manner will be the student very gentle student. Because of this, my goal is to make learning not just about memorizing but also understanding and curiosity. Because of this, I look forward to support and inspire my students to reach their best destination. So let me put you some titles for my today's session for grade 8 student. Here, mathematics for grade 8 student, rational numbers. I put at least 2 outcomes when the student finish these titles. The student might have to now to define the rational numbers after completing this session. The next one is representing the rational numbers on their number lines. This is the major one when we are learning. These outcomes is the basic for the students to follow up. When we come to the introductory part, as I have prepared in this slide, precisely, rational numbers are numbers that can be written at the form of fractions. That means a over b in the form of fraction. This will be rational number. Unless this a and b is numeric numbers. That means a might be 2, b might be 3. That means when we put these numbers, 2 over 3 is the rational numbers. It is written in the form of fraction. Because when we put this number, 3 might be different from 0. Or b might be different from 0. Unless it is equal to 0, that means it emerges as undefined number. Because of this, rational number should be written in this form. When we see these examples, 1 over 2, 3 over 4, minus 3 over 4, 5, 0, 2 over 3 is the examples of rational numbers. When we try to see these properties of rational numbers, The first property one is mathematical operations. The four operations of mathematical: plus, minus, multiplication, division. These four operations should be closed under this category, because when we come to this division part, the divisor is not equal to 0. Is not equal to 0. The next property of rational numbers is it should be positive, negative, and 0. It's must. It's must. And the number of x, when we see in this x-axis, origin of 0, the number from to the left is negative numbers, the number to the right is positive numbers. These numbers maybe is negative, maybe is positive, or 0 is a rational number. It might be written as the fraction forms. So when we see decimal expansion can be terminating or repeating, okay? When we see 1 over 3 is, when the decimal form of 1 over 3 is 0.3333 blah blah. This is infinitely adding the numbers after the decimals many times. That's repeating, okay? Repeating. Another issue is when we see here 1 over 2 is finite decimal, 0.5. 0.5 is what we call it terminating. This one is repeating number. Every integer is a rational number, okay? Every integer is a rational number. Because integer is the subset of rational number. Whole number is also the subset of rational number. Because of this, every integer is a rational number. Okay? Yeah. When we see these examples, as I have taught you earlier, this is the same. When we see this, it's a repeating number. This is terminated decimal numbers. When we compare these ones, it's integers, but it's what we call it rational number. 7 over 8 is a fraction written in the form of fraction. This is also rational number. When we see rational versus irrational numbers, as I have taught you earlier, in the same fashion, rational numbers can be written as a fraction in the form of A over B, as I have taught you, A over B. Okay? Else, irrational numbers cannot be expressed as a fraction. Okay? When we see these numbers, root of 2 is a rational number. Pi, when we convert this, 3.14, blah, blah. This is a rational number, the form of exponential. Thus we call it a rational number. Okay? Rational number. Decimal expansions of rational numbers never terminate or repeat. Yeah, as I have told you, it never terminates or repeat decimal expansions. Okay, this is all about for today's session, rational numbers. Here at the end of the session, I have put you some practice questions, 1 up to 5. Thus, is 7 over 9 is a rational number? You can divide 7 to 9. Then you can get, is it a rational number? It's homework for you. For the next session, you have to be ready these questions, 5 questions. Write 0.25 as a rational number. Yeah, you can compare this one. Is root 16 is a rational number? Yeah, it's really easy questions, elementary questions. You put the note and they come back with answer for this question. If you have on this session, if you have questions, discussions, you are invited to be welcomed. Thank you very much.